Bismillahirrahmanirrahim. Rabbi zidni ilma. Don't feel lonely. The entire universe is inside you. Assalamu alaikum, everyone. My name is Dr. Sadia Rafi, and under the supervision of Professor Dr. Sara Afzal, today my topic of presentation is hypothesis testing for proportions. Kindly, can you all see the logo of recording?
Yes, Dr. Sadia, it's recording.
Okay, thank you.
Yes, Dr. Sadia, it's recording.
Thank you so much. Sorry for the botheration. Today, my topic of presentation is hypothesis testing for proportions. The learning outlines includes introduction to proportions, hypothesis testing for proportions, z-test for proportions, examples of z-test and chi-square test. Learning outcome. At the end of this presentation, participants will be able to describe steps of hypothesis testing for proportions. Starting with proportion, it is a ratio which indicates the relation in magnitude of a part of a whole. Numerator is always included in denominator, and it is usually expressed as percentage. So what is hypothesis? Any statement which can be tested. It is proposed explanation of phenomenon. Hypothesis testing for proportions includes a single population proportion and a difference between two population proportions. Steps of hypothesis testing. First of all, to state the hypothesis, then decide significance level, which is alpha, then compute test statistics, z-test, then the critical value, and then state the conclusion. It is the flow chart of the same thing, which is in this, first of all, we state the hypothesis, then conducting experiment, choosing test statistics, decision making, and drawing conclusion about population. Z-test for proportions. Assumptions of z-test. Large sample size, number one, then the variance known, and the random sampling. These are the three assumptions for z-test. Step one, state hypothesis. To state null and alternative hypothesis. Just for it, if we see the effect of biofertilizer X on plant growth, the alternative hypothesis would be H1, application of biofertilizer X increase plant growth. Where would be the null hypothesis would be application of biofertilizer X do not increase plant growth. So it is H0, which is null hypothesis, and it says it's not. So these are the two hypotheses, null and alternative. So what is null and what is alternative hypothesis? Null is H0, a statement about a population parameter. We test the likelihood of this statement being true in order to decide whether to accept or reject our alternative hypothesis. And it has different signs, lesser, greater, or equal. And the alternative hypothesis, which is HA, is a statement that directly contradicts the null hypothesis. We determine whether or not to accept or reject this statement based on the likelihood of the null or opposite hypothesis being true. And it is three signs is equal to, greater, or smaller sign. How to identify a left-sided test versus a right-tailed test. So two-tailed test is when alternative hypothesis contains the non-equivalence sign. So it means alternative hypothesis is not equal to null hypothesis. And in the left-sided test, the alternative hypothesis contains the lesser sign. And in the right-sided test, the alternative hypothesis contains the larger size or bigger size sign. So you can see in this, if we draw a normal causal curve, and you can see left-sided, right-sided, and if it is not equal. So in this side, right-sided, the rejection area is here, and left side, the rejection area is, and on this side, we both have rejection area on the both sides. In coming slides, I describe you everything one by one. So the first step was to stating the hypothesis. Second is deciding significance level. So alpha, the significance level, is the probability that you will make the mistake of rejecting the null hypothesis when in fact it is true. So it is very important. So the determined critical region usually is 0.05 but can be 0.01 or any other value. You can say it is the normal probability. If this left blue area dark is 0.25 of the total area under the curve, it is again 0.25 and its value is 1.96 over here. On in this side, it is 0.05 and it is on both sides, it is divided, and when it's on one side, it is 0.05 under the curve. If we draw a curve, you can see its significance level is over here. So if our value comes over here, we fail to reject. And if it comes over here, it is reject, it is significant. So this is the rejection area and this is the non-rejection area or acceptance region. Determine critical value. A critical value is the value of the test statistics which defines the upper and lower bounds of a confidence interval, or which defines the threshold of statistical significance in a statistical test. We can determine critical value by z-table calculator, and depends upon if hypothesis is one-tailed or two-tailed. Determine test statistics. These are the formulas of the z-test, which are used for the one population and two population. To clarify this, we go on the next slide, the formulation of these tests for population proportions. It is z is equal to p hat minus p divided by underscore peak over n, where p hat is the sample proportion, which is x over n, whereas this p is the population proportion and n is the sample size. The formula is derived from the normal approximation to the binomial and follows the Jenner formula, which is a test value. Test value is observed value minus expected value divided by standard error. We obtain p hat from the sample, which is observed value, and p is the expected value, which is hypothesized population proportion, and under square root p over n is a standard error. So all this fits in this test value. And the formula is this, can be derived from the formula, which is I have just explained to you, by substituting, by putting all these values and this, then we get this formula. Z-table. Whenever we get the value of the z-score, z-table, calculate the z-score, then we go to the z-table to find out the value. So we have to, according to our value, we go in a row and then in a column, and the way where they adjoin with each other, we take that value. That is called the z-value. Step 5 comes as a stage conclusion. If test statistics falls in critical region, you reject null hypothesis. If test statistics does not fall in critical region, accept null hypothesis. Moving towards one example, it is a hypothesis testing of a single population proportion. The proportion of malnourished children in a rural community is 70%. A researcher believes that this value is not true. He conducted a survey on 200 children and found that 131 malnourished. At 95% confidence level, is there enough evidence to reject null hypothesis? Because it is the alternative hypothesis that the researcher is claiming that it is more than that, and null hypothesis would be that it is not more than this. Moving towards the solution, in the step 1, null hypothesis is 70%, and decimal it is 0.7, and alternative is not equal to. So after dividing p hat value with the sample and divided by total population, it is 0.65. In step 2, we have alpha 2, which is step 2, which is 0.05. As I've already shown you this diagram, as it is not equal to both sided, so 0.025 area here and 0.025 area is over here. It is the value like 95% confidence interval, which is usually alpha is 5, the alpha 8 by the way is 2.5, and table value is 1.96, which has already been shown in it. So by putting the values in this formula, p hat minus p naught 1 minus p naught over divided by n, we will put all the values and we calculated z as minus 1.54. What it means? As you can see in this is a rejection area, this is the rejection area, this is acceptance area. It is the value is 1.96. We have calculated as 1.54 does not fall in rejection region. So we fail to reject null hypothesis. So it would be in the acceptance region. Testing for two proportions. It is a vaccination rate in nursing home. In this example, in the nursing home study mentioned in the chapter, it is a blue man basically, the researcher found that 12 out of 34 small nursing homes had a resident vaccination rate of less than 80%, while 17 out of 24 large nursing homes had a vaccination rate of less than 80%. At alpha is 0.05, test the claim that there is no difference in the proportions of the small and large nursing homes with a residence vaccination rate of less than 80%. Moving towards the solution. If P hat 1 be the population of small nursing home with a vaccination rate of less than 80%, and P hat 2 be the proportion of large nursing home with a vaccination rate of less than 80%. So by applying the formula and putting the values in it, we got this. Now follow the steps in hypothesis testing. In the step 1, state the hypothesis and identify the claim. H naught is equal to P, P1 is equal to P2, it was a claim, and alternative hypothesis is not equal to. For the critical value, alpha is 0.05 and the values are 1.96, positive and plus positive negative 1.96, both sides of the curve. Then by putting the formula, we calculated this and it is minus 2.7. Make the decision. Reject the null hypothesis, that's 0.2.7 is lesser than 1.96. So there is 1.96 is the value and our value calculated was minus 2.7. So there's enough evidence to reject the claim that there is no difference in the proportion of small and large nursing homes with a resident vaccination rate of less than 80%. Z-test and chi-square test, standard error of difference between proportions, SEP1 minus P2, for comparing qualitative data between two groups, used for large sample size only, more than 30 in each group. Standard error of difference between proportion, SEP1 minus P2, is calculated by using the formula. It is given below. Why isn't chi-square? This test is also for testing qualitative data. Its advantage over Z-test is can be applied for smaller sample as well as for large samples. Prerequisites for chi-square test to be applied are the sample must be of random sample, none of the observed value must be 0, and adequate cell size. Talking about the chi-square test for proportions. Chi-square assumptions. Area under curve is 1, continuous distribution and value is always positive. It is skewed to right as the degree of freedom increases. Chi-square looks like normal curve. As you can see, if we have the degree of the freedom 8, it's like this, and if it is 4, it is this, and if that as the degree of freedom is decreasing 3, it is looking like moving towards a normal curve. The chi-square goodness of fit test. Step 1, state the hypothesis and identify the claim. Step 2, find the critical value. This test is always right-tailed. 3, compute the test value. Find the sum of observed minus expected squared divided by expected values. Then make the decision and summarize the results. This is the critical value of the chi-square distribution with degree of freedom. D is the degree. So you can see the different degree of freedoms are given and the values are also mentioned. It's an example. A researcher read that firearm-related deaths for people aged 1 to 18 were distributed as follows. 74% were accidental, 16% were homicide, and 10% was suicide. In her district, there were 68 accidental deaths, 27 homicide, and 5 suicide during the past year. At alpha of 0.10, test the claim that percentage are equal. For this solution is step 1, state the hypothesis and identify the claim. A null hypothesis, the deaths due to firearm or age to 18 are distributed as follows: accidental, homicidal, and suicidal. It was a claim. And the alternative is this distribution is not the same as stated in the null hypothesis. So in the step 2, critical values 0.2, degree of freedom is 3 minus 1 is 2, and its critical value at this 2 is 4.605. Compute the test test. The expected values are as follows. We will calculate all these figures of accidental, homicide, and suicide and applying the formula, and we calculated this value. So the value is 4.605 and calculated is 10.56. Reject the null hypothesis. Since 10.54 is larger, greater than 4.65. So there is enough evidence to reject the claim that the distribution is 74% accidental, 16% homicide, and 10% suicide. Now it's time for multiple choice questions. The probability that you will make the mistake of rejecting a null hypothesis, which in fact it is true, it is beta error, alpha error, power of study 1 minus alpha error. Anyone from the class? Can you hear me?
Yes, Dr. Sadia.
Yes, it's B, alpha error.
It's beta alpha.
Yes. Question number 2. The number of distinctions in a class are 2%. A researcher claims that the distinctions are more than 2%. Which of the following is the most appropriate option? It is a two-tailed hypothesis. It's a right-tailed hypothesis. It's a left-tailed hypothesis. It's a bidirectional hypothesis.
B.
Yes, B is the correct answer. It's a right-tailed hypothesis because the larger sign would be it, and the researcher claims it's more than 2%. So it's B. A researcher wants to compare number of stage 1 breast cancer out of total breast cancer in hospital 1 with the number of stage 1 breast cancer out of total breast cancers in hospital 2. The most appropriate test will be Z test of mean, Z test of proportions, paired t-test, unpaired t-test.
A. Z test of mean.
No, second one, Z test of proportion, because it's wants to compare the numbers, percentage basically. So B is the correct option. A researcher wants to compare two proportions using chi-square test. Which of the following is not true about chi-square distribution? Area under curve is 1, is skewed to right, looks like normal distribution curve as degree of freedom increase, can be skewed to left. Which option is not correct in this? The answer is D, can be skewed to left, because chi-square can never be skewed to left. It is always to right. Question 5. A researcher compared percentage obesity of school children with WHO reference percentage of obesity in school children. Which of the following tests will be the most appropriate used? Z test of means, Z test for single proportion, Z test for comparing two sample proportions, unpaired t-test. The answer is B, which is Z test for single proportion, because it's talking about the percentage. A researcher wants to compare two proportions. He selected significance level 0.01 alpha. 0.05 means there is 1% probability that you will make the mistake of rejecting the null hypothesis when in fact it is true. There is 10% probability that you will make the mistake. There is 1% probability that you will make the mistake of rejecting the alternative hypothesis when in fact it is true. Or there is 10% probability that you will make the mistake of rejecting the alternative hypothesis when in fact it is true. The correct
Alpha.
Yes, the correct option is A, absolutely right, that there is 1% probability that you will make the mistake of rejecting the null hypothesis when in fact it is true. The proportion of malnourished children in a rural community is 70%. A researcher believes that this value is not true. He conducted a survey on 200 children and found that 130 were malnourished. Calculate Z value. So this is numerical. I have a solution. To calculate test statistics, we will put this formula of Z test, and by putting the values in it, we will calculate it. It is minus 1.54. So C will be the correct answer. Question 8. A researcher did study on proportion of smokers in an office. The Z test of proportion came out to be minus 1.29 at 95% confidence level and alpha 0.05. The critical value is plus minus 1.96. What should be done? Accept null hypothesis, reject null hypothesis, accept alternative hypothesis, or not enough evidence to comment. Any guesses?
B.
No, it's A, because our value is minus 1.29, and as you can say, plus minus 1.96 is on the both sides. So minus 1.29 is larger than 1.96, so we will accept null hypothesis. Calculate degree of freedom of a system that has 5 variables and 4 equations are known. So again, this is a solutions-based question. For this, for the degree of freedom is equal to number of variables minus number of equations. So in this scenario, there are 5 variables and 4 equations. So simply it would be 5 minus 4, and that is 1. So option C. Calculate chi-square value if observed value is 4 and expected value is 6. So the solution is, as we know, chi-square is equal to observed minus expected O square divided by E, and by putting the value, it would be 0.66, which is option D. This is my key. This is our YouTube link. These are my references, and thank you so much.